Higher education is facing a measurement crisis. While perfectly formatted essays rapidly appear in submission portals, the students behind them often cannot explain the basic choices made in their own work. The consistent gap between the quality of a written artifact and a student's actual understanding suggests that take-home essays are losing their utility as a measure of individual comprehension. Many institutions have responded by relying on automated AI text detectors to police these submissions. However, this approach is reaching a mathematical dead end. These detectors measure predictability and structural variation. Because clean academic writing is highly predictable, algorithms frequently mislabel structured human prose. This creates an equity failure. Non-native English writers often use structured patterns, resulting in disproportionate false positive flags for marginalized students. To find a more valid assessment, educators are returning to the viva voce, or oral examination. This method requires real-time reasoning and active application of knowledge, making it significantly harder to outsource. The shift from policing text to verifying cognition has historically been blocked by logistics. A 25-minute oral exam for a single cohort of 36 students requires over 30 hours of faculty and grading time, making it unscalable for most modern institutions. At the NYU Stern School of Business, researchers recently deployed a system that automates the Socratic method using voice AI. By utilizing a multi-agent voice AI architecture, the school successfully administered personalized, rigorous oral exams without the traditional constraints of faculty scheduling. The economic metric of this system is the primary driver of its scalability. The marginal cost per student was exactly 42 cents. This represents a massive reduction in the cost of assessment, as human administration for the same 36-student cohort typically requires roughly $750 in labor. This efficiency is not the result of a simple chatbot. The system employs a highly structured state machine that guides the student through specific phases of evaluation. Automating the Socratic method makes high-fidelity, personalized dialogue economically and logistically viable at an institutional scale. The examination pipeline uses an orchestrator that routes a student's call through 3 sequential agents: authentication, project discussion, and case discussion. Students log in at their convenience within a multi-day testing window. This asynchronous design accommodates different time zones and eliminates manual scheduling. Decomposing the exam into 3 distinct agents prevents conversational drift. Isolating each phase ensures technical hurdles in authentication don't compromise academic evaluation. The primary assessment happens within the project discussion agent. Using dynamic variable injection, the agent ingests the specific details of a student's prior written work before the conversation begins. The AI agent uses this context to probe the student on specific methodological trade-offs, asking them to justify their decisions in real time. This exposes a critical vulnerability. Students who outsource their writing to an external model cannot improvise a consistent verbal defense of those choices. When written work can be generated instantly by an external model, real-time verbal defense provides a verifiable indicator of comprehension. Deployment revealed that advanced conversational models can experience significant instability when managing the rigid parameters of an exam. One major failure mode identified by the researchers was question stacking. The AI repeatedly fired off compound, multi-part questions in a single turn. This creates an unfair cognitive load for students attempting to formulate complex answers under pressure. A second failure occurred during the case study phase, involving non-random selection. Despite being given a list of 8 cases, the AI fixated on the Zillow case study 86% of the time. When Zillow was removed, the agent instantly shifted its fixation to a predictive policing case. This data anomaly highlights an inherent ordering bias in large language models. They are statistically incapable of performing true mathematical randomization on their own. These behaviors cannot be corrected through simple prompt instructions. They require architectural fixes, such as deterministic code and programmatic turn validators that reject multi-part responses. For education, behavioral constraints must be strictly enforced through the system's underlying code, rather than relying on the AI's independent discretion. Capturing the exam is only the first step. The final logistical challenge is reliably grading a 20-minute audio transcript at scale. Using a single AI model for grading is unreliable. Different models exhibit varying leniency, creating high variance in scores assigned to the same transcript. To address this, the system uses a council of LLMs. A single transcript is evaluated independently by 3 separate models: Claude, Gemini, and GPT-5. In round 1, each scores the student across 5 dimensions, citing verbatim transcript evidence to support deductions. Round 2 introduces a deliberation phase. The models review each other's scores and evidence, forcing them to justify their initial grades or revise them based on the reasoning of their peers. This corrects for individual model bias. For example, the Gemini model consistently lowered initially lenient scores after seeing stricter, evidence-backed arguments from other models. Finally, a chair synthesis model compiles these deliberated scores into a finalized grade report, complete with a structured breakdown of strengths and weaknesses. As a safeguard, the system flags any exam with high intermodel disagreement for human audit. AI handles the volume, while humans evaluate edge cases. By layering models into a deliberative consensus, individual AI biases are moderated to create a high-reliability grading instrument. Aggregating these exam results allows the system to evaluate the performance of the faculty alongside the students. This revealed a specific discrepancy at NYU known as the experimentation gap, which appeared when comparing human-assigned grades with those from the AI Council. This comparative bar chart shows lenient human grading contrasted against the strict, evidence-backed deductions of the AI Council. The gap reveals human bias. Instructors give credit based on what they know a student intended to say, whereas the AI grades only what was actually articulated. Surfacing these class-wide blind spots identifies specific teaching gaps that lenient human grading often overlooks. Faculty can use this data to rapidly redesign their curriculum, ensuring that future lessons directly address the areas where students struggle to demonstrate competence. Scaling the Socratic method via voice AI provides a diagnostic tool for pedagogy, reflecting the effectiveness of both measurement and instruction.